before I present Roberto with his talk, a small announcement, the evening event from GData. Small words to me, I'm 101. I have finished my master's thesis here in February and now work on mobile research by GData. And here's the event, I think you know it. We present food, drinks, and some discussions, I hope so. Nice discussions, and perhaps also some discussions about master thesis, bachelor thesis, or something like that. Yeah, it starts at 6 p.m. and also I add some possibilities to reach us. It's a Knappschaft bus station, or you walk from Wasserstraße. I think it's shorter. And now here's Roberto from Belgium, and he gives us a talk about cross-content scripting, yes, attacks and exploits. Yeah, give him a warm welcome and.
Thank you.
Yeah.
Thanks. Okay, thanks for coming today, and a big thanks to the sponsor, because I think the initiative, it's very cool, especially for you guys. I don't know any other university who does this kind of program, inviting external speakers. So I think it's very cool. I also checked the previous speakers, and I'm actually flattered to be part of the list. Okay, today I'm going to talk about cross-content scripting attacks and exploitation. So subtitles basically is from alert XSS, so alert 1, how can I get to MetaRPT shell? And this is a talk which is part of my research in the last, I would say, 3 years. So I put all together in this talk because I want to show you all the evolution. And before getting to the outline, the agenda, a short introduction myself. I'm basically spoke on various different conferences around the world, DEF CON, USEC West, Hack in the Box recently, and some of the OWASP conferences. And I do research as my own time. It's a passion of mine. I'm not an academic researcher, and I publish time to time some of my research on my blog, which you can see there, and I use Twitter time to time. All right, so outline for today's talk. Basically, it's a short introduction what cross-content scripting is, and then a section will be dedicated to past research I've been doing, and then there will be recent discoveries, so bugs that I found recently. And the last part will be, well, very food for thought in terms of further attack surface for cross-content scripting. Okay, first part. Some concept before we start. Probably most of you heard about the same origin policy. This is a very important security mechanism in modern browsers. And what caught my attention when I was reading and doing researches on the web is the definition from the W3C website, which says the overarching intent is to let users visit untrusted websites without those websites interfering with the user session with honest websites. And the point is that it's like it's talking between two different websites. But the same origin policy is more than that. It's not just checking if one website is trying to access or doing bad things on another website. It's also checking if, for instance, a website is trying to get into your local file system. And if that attempt occurs, then the same origin policy should prevent that kind of attack. So it's not just between different websites. It's more than that. And here comes in terms of cross-content scripting. So what it is, it's basically an injection from an untrusted page, so an internet page on the web from the HTTP protocol, into a trusted zone in the browser. And when I say trusted zone, it's something you might be familiar with. If you just check on the list on the bottom of the slides, you can see that each browser has got a trusted zone, a privileged zone. Firefox, for instance, every time you install an extension, the extension will work using the Chrome zone, which is a little bit confusing, but the Chrome zone is a trusted zone in Firefox. And then other browsers, they have their own zones. And I will show you examples when we show the demos and demonstration and the bugs. So this is a very simple diagram. I don't know how to design diagrams. I'm actually not big. Just did the vision in a few minutes, but this is what I just tried to explain to you. It's in one picture. So you go to a malicious website. Malicious website try to inject something which will be rendered in a trusted zone. And that can be Chrome vulnerable trusted zone, or can be added zones. And this is another part which is important, because when I say trusted zone or privileged zone, what do I really mean for that? It's that zone where the browser can do things which normally a web page can't do. So for instance, if you're changing the configuration of your browser, like changing settings, I don't know, the proxy, you are in a zone where you can actually changing the configuration. So basically you're probably changing a file in the browser folder. Or bookmarks, so you're adding or managing bookmarks, things which belongs to your trusted zone. The same with storage in the browser, like the cookies. So the cookies, it's depending on the browser, they can be stored in the file system on a SQLite database. All these kind of things represent trusted zones. And the same with the operating system. So from one part of the browser can talk directly to the operating system APIs. For instance, it can talk with the file system or with the network libraries. So this is some of the examples. And the example I showed before, I talked before, is the Firefox model. So when you install an extension or add-on, then the add-on has ways to basically talk directly with the operating system. So let me give you an example. This is FireFTP, Chrome extension. And Firefox there, on the URL, you can see it's Chrome URI. And FireFTP basically is the FTP client. But what you can see from this screenshot is that the FireFTP extension is reading my local file system. So it's got the permission to do that. It can read the local file system, and then it can copy files to other FTP servers. And that's actually showing how the Chrome zone is powerful, because suddenly from that zone, one extension can actually interact directly with the operating system. This is another example with the Chrome settings. When you change settings here, you're making modifications in the configuration of the browser. Same with the Opera history. This is another trusted zone. Why? Because it's showing the history. And to show the history, it must read some files. It must do something with your local file system directly. And this is something that a web page should never be able to get to, because of the same origin policy. So in terms of exploitation, these kind of bugs, when we can inject content directly into a trusted zone, and when I say content, I say JavaScript, in terms of exploitation, they are always reliable, because the JavaScript will always be executed. It's like by design. And I'm not talking, there are no memory corruption bugs involved. And the thing with the JavaScript injection is that once you're in the trusted zone, then you can, depending on the browser platform, you can directly or indirectly talk to the API, to the privileged API. So in terms of exploitation, it comes to a challenge. The first thing you have to do if you're looking for this kind of bugs is, one, you have to find the injection point where you can inject JavaScript content. And the second, if you know and you found the injection point, how can you make the JavaScript to interact with the trusted APIs? So I want to give you some example of bugs which I discovered in the past. And before my research, of course, there were other people that were looking at these kind of issues. And starting from 2005, we have example of people finding bugs in Firefox extensions, for instance. Starting from 2005 with the Grease Monkey bug or Sage cross-site scripting by PDP. And then there was a very cool presentation from Kuza55 and Stefano Di Paola. And they were talking about attacking rich internet application, which gave me the inspiration to do research on browsers. And these people were actually showing bugs in Firefox extension, and actually explaining what was the impact is that you're not just doing you don't have the same impact you have with standard cross-site scripting attacks. You have more because you have JavaScript running inside the Firefox extension. Then, with that kind of privilege, you can do the same things that an extension can do, and that was the real new side of impact of this kind of bugs. And I tried to do some research in browsers too, and I was looking at Opera, and I found a way to find a cross-site scripting inside the Opera history page. And I'll show you this in a few slides. And then from that, I moved into Firefox extension with my ex-colleague Nick Freeman. So we found a lot of Firefox extensions which were vulnerable, and we found a lot of bugs, and we published a lot of exploits, which I'll show you as part of this presentation. So this is the Opera cross-site scripting history. It's old bug. It's from 2008, and actually one guy from the Metasploit community, Egypt, made a Metasploit module for this bug because it's very easy to write. So how does it work? You have the injection from the history happens with the location.hash. So you visit a website, and after the location.hash, you can put your malicious payload. That malicious payload is not filtered when you go and visit the Opera history page. So what happens is that if the user goes to the Opera history page, that JavaScript which has been injected will be executed inside the Opera history. And as you can, I don't know if you guys can actually see the red line. That's basically the injection after the location.hash. And what it's doing is pointing to a script, and the script is generated by Metasploit, which contains the exploit, basically the exploit to execute inside the Opera history. And this is the second step. So we got a user goes to the malicious website, the injection occurs, but then we need a way to trigger the injected payload in the history page. So what I did was to do a redirection from the internet page to the Opera history page. And that was a same origin policy bypass. And the reason why is that from an internet page, I should never be able to go to a trusted zone because the protocol mismatch. So HTTP to Opera. So because of the protocol mismatch, same origin policy should have prevented this kind of redirection, but it didn't. So I was able to basically jump into the history page where my injection was basically stored. And I don't know if guys, it's a little bit small, but this is the payload which was injected with the JavaScript. And the technique here is very simple. So because we are in the Opera colon zone, trusted zone, what was possible to do was to change the configuration of the browser. And the scope was to get code execution. So one technique was to change the mail application handler. So you know, like when you have you're using Windows system, you might have by default Outlook. So in Opera, you can change the mail client, your favorite mail client. So because we are running inside Opera, the cross-site scripting could get the preference, change the preference to point to, here this is for the Linux operating system. You can see it's pointing to bin bash, cmd bin bash, it's the red one. So whenever there was a redirection to a mail to handler, then Opera was calling whatever I was setting here with this payload. So the next step of the payload was to basically force the browser to load a mail to address. So that will push the browser to connect to call the mail application handler and then get the code execution. And I'll show you a video I had. See if it is. So this is the, let's see if I can make it more big. Yeah. So this is the, I just loaded Metasploit, and this is the Opera module. And basically, I just say, okay, exploit. The URL you see there is the malicious page. And this is the vulnerable Opera version. Of course, it's the old one, 952. So basically, you point the browser there, and you already have shell. And this is exactly showing the technique I just showed you before. So it's a very nice technique. It's just give you an example how inside a browser zone you can change like configuration, then change the mail handler, for instance, and then force the browser to use the new mail handler. Okay, this was the Opera, and to be honest, when I discovered this bug, I published that on full disclosure. But my proof of concept was not this one, was like just dumping the history. Because I didn't realize myself I could actually be able to change the configuration of Opera. So when I published the proof of concept, other people like Kudza55, Stefano Di Paolo jumped in the thread and say, okay, you can read the history, it's cool, but is there anything else you can do? And so that started the discussion, the full disclosure, and then I was looking more and say, oh wow, actually yes, it can be done more because you can change the configuration of Opera, and then another guy who was in the thread found a way to change the mail handler and say, wow, this is cool. So now you can get code execution, not just reading the history. And that made me think about, wow, this is cool. So probably I should keep researching this because across the scripting now is starting to be a code execution if you find the right point and the right trusted zone, and if you know how to use the trusted zone as well. So I did research with my ex-colleague on Firefox extension, and this is, well, still today it's an issue because if you have a vulnerable extension, you can be fully compromised. And when we were doing the research back then in 2009, I was a shock, but just for the exercise of this presentation, a few days ago I installed a vulnerable extension on the latest Firefox. Nothing changed. So if the vulnerable extension is there, you can be compromised. And I'll show you a demo. But the most important thing you probably should get from this slide is that the security model for extension, it's almost non-existent. So to give an example, if you install an extension, the extension can modify another extension or can do things with your operating system. You don't know exactly what's going on. And I don't know if you guys remember, there was an issue actually between NoScript and AdBlock Plus a few years ago. Actually, the author of NoScript made some modifications in a way that his advertisement will still be shown even if you had the AdBlock Plus installed. So there was a little bit of war between the two authors. But this shows you that there is no boundary between different extensions, and that's a little bit scary. And after 3 years, still the same issues. So here it's a list of extensions we found vulnerable. These cool previews, I don't know if you guys ever used this one. So basically, if you have a links in one HTML page, you hover with the cursor of the mouse and will show you a preview. So you don't have to click the link, it will just show you the content in a different window. And these cool previews has this function which is called add to stack function. So basically, if you right click on the link, you can add to the stack the link, the address, the website you are pointing to. And what I found in this case, if the link has got the data URI and a base64 encoded payload with your special JavaScript payload, then that payload will be executed inside the extension itself. and then you can get code execution because it's executing within the Chrome zone. And this is a screenshot of the exploit. So here I'm just invoking cmd.exe. And the way I'm using this, it's the way the extension work. So extension, they use xpcon components in Firefox. And there are many xpcon components here. I'm calling the NSI process one. And basically I say, okay, call win.com, and win.com called cmdx. So you can see the cmd prompt popping up. And Firefox is actually shipped with a lot of, I think, thousands of xpcon components to give the functionality to the extension. So with the extension, you can do pretty much whatever you want. And this is just using the basic ones. And I'll show you a demo on this one, which I got here as well. So this is just to make the point. I was testing 16.0.2, and I have cool previews. So if you go over a link, what it does, you see the icon there. It will show you the content of the link in a different window. And then you have this add to stack function. And this is my payload there. And what you see there on the first one is the malicious link with the data URI. The base64 encoded payload is basically what you see in the bottom decoded. It's the same script, same payload I just showed you in the previous slide. So this is, I'll show you other examples of vulnerable extension, but again, the Firefox model hasn't changed in the last few years, so this is still possible. It's possible to do it. See, I'm showing all the xpcon components, and here it's calling cmdx. So if I do a right click there, and this is the add to stack vulnerable function. Here I'm showing process hacker. This is the Firefox process, and this is what happens. And there you see that win.com was pawned by Firefox.exe, and then win.com called cmdx. So it doesn't matter if you have the latest Firefox, but if you have vulnerable extension, this is what can happen. And then we start to have fun. So we say, oh, wow, this is cool. So keep going on with what we're doing, like going to the Addon's Mozilla website. We were trying to find the most popular extensions and then try to find this kind of injection bugs. And one that my colleague found was FireFTP. And the injection point was very cool because it was in the welcome message of the FTP server. So if you're using FireFTP to connect to a FTP server, and the welcome message was having JavaScript inside, and JavaScript was rendered inside the Chrome zone, and then you could get execution again. Another one is the feed sidebar. I guess this is another issue with the RSS feed, and you will see that in the rest of the presentation. We found that many RSS viewers vulnerable to these kind of issues. Why? Because by design, RSS take feeds from untrusted sources like the internet. The problem is where they render the content. And again, many of the RSS authors failed. And if you have RSS feed with iframe inside the description tag, then you could get code execution inside Chrome. This is with the feed sidebar. Sage was another one. And description tag was the injection point, also the link. So even if, let's say, the user click on the link of the RSS news, whatever, again, code execution or JavaScript will start rendering inside the Chrome zone. So again, that's privileged. InfoRSS, another one, same story. This was different. The injection point was different, and the action required by the user was different. So basically, also the extension changes also the exploitation scenario, because extension makes the user do things which normally a website doesn't do. But in this case, it was a drag and dropping action. So what you could do is like, you could take a picture, drag it, and drop it inside another, basically, window. And that window was rendered in Chrome zone. So if we were grabbing a picture, which was having like something like all load, and then the malicious JavaScript, then that will be rendered inside the Chrome zone. Of course, that requires the user action, the drag and drop. But again, if you take the average user, you wouldn't check the HTML attributes, so it would just take the picture and put it there, because drag and drop is so an easy gesture to do. And that was a very cool thing. So you just drag and drop and then execution. Now I'll show you some of the exploits, because just to make the point. This is an exploit. If you find a vulnerable Firefox extension, you can use it to steal all the passwords which are stored in Firefox. This is just to show you another way. So again, it's using XPCon components, and it can read all the passwords. Then what it does is send all the passwords out to another website. Local file disclosure, you can just point an iframe to whatever file you want to see, and then you set a timeout, and then with JavaScript, you read the content of the iframe. And this is possible because you are in the Chrome zone. So because you are in trusted zone, privileged zone, you can do that, because you are acting as an extension does. This one was one which I showed in DEF CON, just to make the point, and people were actually confused. I say, well, if you have an extension which is vulnerable, you can actually compromise NoScript, because many people thought that having NoScript would protect against these kind of attacks, but it doesn't. Because NoScript by default has the Chrome URI zone whitelisted, because it has to work from Chrome as well, because it's an extension. So the trick was to change and add a malicious website in the whitelist, and that was cool. Actually, create some thread in the forum of NoScript. Many people were not really happy about the fact that we showed this kind of payload. And then we start to be like more and more having fun. Like my ex-colleague was doing a reverse VNC using XML HTTP request. So the trick, the challenge here was basically to, with the binary, you had to do a little bit of play, as you see in the bottom part, with the stream and the binary. And but it was just using a simple XML HTTP request to do a binary operation, which is very cool. And again, this is allowed if you are in the trusted zone. So now, this is past research. Now let's get to the recent stuff. Starting with Maxthon. Is there anyone here who used Maxthon or knows Maxthon? Only one guy? Okay. Two? In the last Hack in the Box conference in Amsterdam, I was presenting about different bugs, and I was presenting about Maxthon, and I released, I think I released like 5 0 days. And what I did before releasing the 0 days, of course, I sent the report to the vendor. I share all the bugs. But I just got a reply back saying, okay, thank you for your report. Then I try to chase the vendor, say, okay, what's going on? And they say, a developer is looking into the matter. Then I try to chase, but no response. So I decided, okay, I'll drop all the 5 0 days. And this was in May 2012. And then I say, okay, I'm not going to do the advisories for these bugs. I'm going to hold it, see if the vendor fixes. But after 25 releases of Maxthon, because what these guys do is like they release a new version every week and a half of the browser. After 25 releases, still no fixes. So I say, okay, now I'm gonna actually weaponize. I'm gonna make Metasploit modules for the bugs I found. And this is the new part which I'm showing here today. So, first bug, which is very similar to the Opera one, actually is identical. So you do your injection after the location.hash, and you probably can guess where it gets rendered, in the history page. And it's the same stuff. So then I can do the redirection to the history page, and then my injected payload will be executed. RSS, So Maxthon has a RSS preview thing, and so if you point the Maxthon browser to an XML page, which is RSS format, then it will preview in a nice way, and that's vulnerable as well. And again, you have all the injection points in the different parts of the RSS, like in the description, the title, and the link tags. So, in terms of exploitation, so I said before there were 25 releases, but something has changed since I presented. They make more difficult things, well, they changed things in a way that made more difficult my life, because before there were ways to invoke some APIs in Maxthon to launch directly an executable. After some releases, they remove those APIs. So the only thing which I could do, and I can do now, is to, if I can inject in a trusted zone in Maxthon, I can read and write files on the operating system. But I cannot directly execute anything. Before it was possible, and I'll show you. So as a personal exploit challenge, I say, okay, I don't want no user interaction. I don't want the pop-up to warn and stuff. And I'm targeting two Windows XP and Windows 7. So in Windows XP, it's very easy. So since I can read and write, I will overwrite an executable, like Outlook Express. And then I call window.location, which points to a URI, which is supported by Outlook Express. And with no user interaction, then if I compromise Outlook Express executable, then my new executable will be executed. And works fine. In Windows 7, it's a little bit more difficult because if you do the same approach, then a warning will show up, say, oh, you're trying to execute, the browser is trying to execute another executable, do you allow yes or no? I didn't want that. And so I was starting to think, how can I do this? Can I touch the registry IVs, or can I touch the registry in some way? And I say, okay, let's be really dirty here. And what I will do is to overwrite one of the Java executables. So what I noticed that when you go to a web page, and the web page has a Java applet, the browser will call, will actually execute jp2launcher.exe. jp2launcher.exe will call java.exe to load the Java applet. So I say, okay, since I can write, what I will do, I will overwrite jp2launcher.exe with my exploit, and then point to the browser to a page which has the Java applet. And it works. And there is no pop-ups and anything. This is, I'll probably show you after. I want to show you the demo now. So this is the first one, the cross-context scripting in history, and the ways to override the Java. Okay, this is Metasploit again. This is the Metasploit module which I wrote. Here I'm showing the jp2launcher.exe, and this is the Maxthon browser. So here just showing that the history is basically, I'll clear all the history there. It is the trusted zone, the about history page. And I believe if they didn't, well, in the meantime I'm talking, there is no new release, that should be the latest version of Maxthon. And here I'm showing the size of jp2launcher.exe, which is 35 kilobytes in the original file. So here I just launched the exploit, and that will provide the attack page. So again, you point there, and this is what happens. So Maxthon is loading the jp2launcher.exe, but at the moment it's doing that, jp2launcher.exe is already been compromised because it's been overwritten with the Meterpreter executable. So the Meterpreter is talking back to Metasploit, and now basically you are in the machine where Maxthon is running. And yeah, this is I would say this is the power of this kind of bugs. And the thing about same origin policy, why it doesn't trigger is because from the web page I'm not doing anything bad with the inside zone. The problem is that the injection occurs in the trusted zone, but there is no correlation between the two directly. Same origin policy triggers when there is a direct operation on something which is not expected or is not allowed. And this is an issue if you have browsers like this where they take input from outside and they don't do filtering properly in the trusted zones. And this is the other demo. Which the difference is that it's showing is that I'm not using Java, so I'm just using the Maxthon DOM objects, and in particular I'm using Maxthon.program. So this particular object is basically available if you are in the about history zone, and you can use Maxthon program, and the program API is basically designed to launch executables by design. I don't know why they did that, but it was there in the previous version. So this is the about history. Again, this is the, I'm going to put all these videos on it. But here the difference is that this is the previous version of Maxthon. So they did some changes. And here I'm using just the console to show you. So this is the Maxthon. This is a special object. It's the privileged trusted API. And there you see the program one. And you see how many things they have. It's quite interesting. And then you have the launch functionality. And again, I'm cleaning all the history. I have my Metasploit launched with the module. So again, here I'm not touching Java. It's just working using the API which are available by Maxthon. And the difference you see here is that there are two shells. 2 sessions from Interpreter because the injection occurs twice. So in the latest version, they fixed one injection, but they still allowed the other one. So now, well, instead of getting 2 shells like before, you get only one, but you still compromise it. Area just showing the same as before. Cool. And this is the RSS one. And you will see the page is slightly different. Here I'm using the Java trick to compromise the Windows 7 machine. Again, this is the latest, should be the latest version. These are not patched. So the thing is, I don't know, the Maxthon says there are 100 million of users. It mostly used, probably they say it's the second mostly used browser after Internet Explorer in Asia. So this is, to me, it's a little bit crazy that they're not taking care of these kind of bugs, which is very simple bugs. It's just an injection bug at the end of the day. But they are exposing so many users to this kind of attacks, which is totally... Sorry?
Are they funded by the Chinese government?
Probably yes. Probably yes. But the West side can take advantage of that if you think the other way. And here I'm showing the same trick, but in the I'll show it here. So this is the RSS preview functionality Maxthon. So if you point to an XML RSS format page, this is what you get with Maxthon, and you see it's a HTTP page. But what it's rendered there, it's rendered inside the trusted zone of Maxthon. So again, you can put whatever code there and will be executed inside the trusted zone. So here again is launching JP to launcher.exe, which has been already overwritten with the Meterpreter executable, and then it's talking back to Metasploit. Cool. Then there was another issue with Maxthon. This has been patched. So basically, when you install Maxthon for the first time, you will be redirected automatically to this website, which is imaxthon.com. And this page is special. It's like a trusted page on the internet. And as you can see there in the screenshot, what it caught my attention, but I think it will get your attention immediately, also your attention immediately, is the two tabs there, like last visited pages and most visited favorites. So if you click there, it's actually showing you the last visited pages. And I say, wow, I'm on the internet, and the browsers, and this website can actually read my history, like the last visited pages and the most visited favorites, something strange here. So what I did is the same approach I showed you in the demo before. I was checking to the DOM of this page, and I actually noticed there were two objects. One is the runtime, and one again is the Maxthon one. And those were responsible to provide that functionality to the user. But the problem which I found the iMaxthon.com is that, one, the first issue is that it's served over HTTP. It's no HTTPS. So if you have any man-in-the-middle attack, you can take advantage of this design. Again, if you have DNS compromised, you can take advantage. If you find a cross-escating bug inside the iMaxthon.com website, you can take advantage of that. Basically, what you can do, you can execute the Maxthon, the two objects I showed before, to do things with your system. And I'll show you a demo on this part. This is the previous version. And here, I suppose that the iMaxthon.com domain is just has been compromised, DNS has been compromised, or like someone is using an insecure Wi-Fi, and iMaxthon.com points to another IP address. In this case, is pointing to my localhost machine. And as you probably see now, the thing is, there is also another nice feature you would see now. So this is what happens. It just spawned the shell, because I went to iMaxthon.com, but iMaxthon.com is pointing to my website. My website contains the payload to trigger CMD-XC. But what I want to show you here is the green icon. So it says it's valid, but it's resolving to my localhost. So it's even fooling the user into believing this is the real iMaxthon.com. That was shocking. And here again, you see with Process Hacker what happened. What I did in this case was to write a file, a bat file, and then inside the bat file just invoke cmd /k, and then execute the dir content. And you can see actually from the Process Hacker, you can see all the commands which were passed. And this is the payload in the page. So that page has got the script there, and the script is just invoking the Maxthon special trusted APIs. And so it does, it creates the temporary file. All these functions are there, available. And they can be invoked from the iMaxthon.com. This issue is now being patched, but before you could do that. And that's why I said if you have a cross-escating, before you had a cross-escating into, well, you can still do it now, but you have to target the previous version of Maxthon. If you had a cross-escating into iMaxthon.com, then it's game over, because you can inject the same stuff and it will work. And here, I'm just showing the thing is from iMaxthon.com, I can actually access the Maxthon trusted APIs. And again, I have the Maxthon.program one, which is available. Okay, this is all the bugs I found with Maxthon. Then I took another one, another Chinese browser, which is Avant browser. And this is kind of hybrid web browser. And there are two versions, from what I know, is the light version, which is you need to have IE, and then you have the ultimate version, which you can also basically use the rendering engine of the other browser, like Firefox or Chrome. And it's quite interesting. If you check download.com, this browser's got more downloads than like Chrome, for instance, on download.com. So I guess some people are using it and downloading it. So a little bit about the structure how it works. So here I launched the Avant browser, and I set the Avant browser to use the Firefox rendering engine. And there you can see basically a reference to the firefox.exe. But the thing you see on the top is that it's not pointing to the real Firefox. It's pointing inside the Avant browser folder, and it's pointing to a firefox.exe, which seems to me like a wrapped version, like a recompiled version to work with Avant browser. And then you see the firefox.exe executed with arguments, which I don't know anything about. This is like all undocumented. You don't find anything about this in the internet. And then what I found, look inside the folder of where Avant browser gets installed, is some files in the res resources folder, and these files contains all reference to the trusted zones or trusted pages in the Avant browser. So for instance, the home.tpl file is basically the browser home zone. So if you use an Avant browser, you point to browser home, it's actually reading this file, home.tpl. So what I did was, okay, let me have a look inside here and see which kind of special function or special objects, trusted objects are available and what I can do. And this is part of the exploitation. If you're trying to exploit this kind of bugs, you need to understand how to invoke the trusted APIs or special objects. And I found this function, which is Windows, in the Windows object, it's called af-run command, which is quite, it's a good name. It's like, oh, run command, so probably I can do something with that. And so I tried to reuse the code which was in those special pages. And what I noticed that you have to pass an argument to that function. And sometimes it's like an integer. And what I noticed that to display the history, the integer 60,003 was used. So you have to pass that integer to get all the history dump, basically, of the browser. And then you have other integers there, which does other things. But the funny thing is that if you do that inside a try to catch the exception, if you're like passing invalid arguments, the browser doesn't return anything. So it's not helping you to understand how it works. You don't get absolutely nothing from the browser. So it's like a brute force, blind brute force. So you pass the integer and then you see what happens. But it's very difficult because sometimes you have like one number which reloads another tab, so you lose your brute forcing or like close the browser. Or it's all undocumented, so I don't know what these numbers does. But what I know is that 60,003, for instance, gets all the history. And this is the number I'm going to use in the exploit I'm going to show you. So this is another one which is unpatched. Same history with Maxthon. I reported to them, but they didn't bother to fix. So this is an interesting one because basically from an internet page, you set an iframe. You point the iframe to the browser home page, okay, which is the trusted zone. And then what you do is like you make a reference to the iframe, and then you invoke directly the special af-run command, and it will work. So basically, you bypass the same origin policy because you're executing a function, a previous function inside the browser home, and browser there is a protocol, application protocol mismatch from HTTP website. So in theory, the same origin policy should trigger in this case, but it doesn't. And so what I did for this one is to develop a BIF module for this bag. Actually, this is I'll show you the BIF module here. It's very simple. And it's actually doing this. It's creating an iframe here. And then basically, this is the arguments passed through the BIF framework to that. Here, the ID, in this case, it will be 60,003 because it's the one that we know will dump the history. Okay, and this is the demo. So this is the Avant browser here, and I think this should be the one of the latest version. Yes. And now the Avant is pointing to a page which has a hook to BIF, and this is a simple hook. So basically now this browser can be controlled through the BIF framework. This is the BIF user interface, and this is the module which I wrote to exploit this kind of bug. So basically you select, okay, Avant, and you go there and say, okay, I want to pass the integer 6003 and execute. And you wait a little bit, and what it does is that the hook will send that command to Avant browser, will create the iframe, execute the iframe command, and get the history. And this is the content of the history, which you can get now with BIF. And this is what it does. So it creates the iframe. Inside there, you can see part of the browser home, the trusted zone, which shouldn't happen because it's from HTTP. And what I'll do when I will release this BIF module is that the iframe, you don't see the iframe. This is just for you. You see what it does, but it will be invisible, so the user doesn't even understand what's going on. All right. This is another one in Avant browser. Again, same history, but this is a different injection point. So if you browse any website and the web page has a title which contains the injection, it will be rendered into the browser home trusted zone. And this is another one. I'll show you here how it does work. So you can see from the title there on the top, there is the injection there. And again, this is a little bit different from the others because what I cannot do, difference with Maxthon, I cannot jump directly into the browser home to trigger the payload. So basically, the user has to go there. Once he goes there, the JavaScript will be executed. So it's a basically two steps exploitation scenario. In Maxthon, I could just do the bridge, so just force the browser to go there, and then. So in this case, the browser goes to browser home. As you can see, this is the browser home zone, and you see like most visited history and recently bookmarked. So if the user goes here and he wants to check the history, this is what happens. The JavaScript will be executed because it's stored there. It's just waiting for the user to go to the page to be executed. But the thing is, again, there's no input validation, and this is a very simple bug. It's from the title. So from the HTML title tag, you can inject stuff into the browser home, which is a little bit disappointing. And then there you can see the injection. Actually, I'll show you what happens there. You see the element there. This is the picture, and then you have another picture there, which is the one which has been injected. The picture will never load, so when the on error event handler will be triggered, and then the JavaScript will be triggered inline. Then there is another injection point, but this is a little bit different because even also Avant browser has capability to show RSS, and this is only when the rendering engine doesn't have that capability. So in this case, Avant browser is configured with the Internet Explorer, and show you another short demonstration. The difference in this case is that I cannot invoke any trusted or privileged API. So I can only do basically standard JavaScript. So on the worst, you can inject a beef hook inside this page and it will be working, but you cannot jump to the browser home page. So this is what happens. Actually, I'll show you a little bit fun because this is going fast. So I'm going to a HTTP website. Then Avant transforms the HTTP URI into a feed colon / URI. You see there in a few seconds, you see the feed there in the title. Then this zone becomes like privileged. And the injection then occurs in another zone, which is browser, which you can see in the window which just spawned there. And this is the zone where the injection is occurring. Of course, this zone here, it's not the same in that you saw before. So I couldn't find a way to jump in the other one to do privileged things. But still, this is an input validation issue, and you can totally compromise a user through RSS with a cross-site scripting. And yeah, this is what's showing the feed URI, which is quite interesting. But then the location where it occurs is browser, so there are different zones. And again, this is not documented. You don't find anything on the web about this kind of zones in Avant browser. And this is the injection description. Then if you click also, it will be, it's just injection a bit everywhere. And this is just showing the RSS. Very simple. I don't have to use any special encoding. It's like HTML encoded. There's nothing fancy. It's just, and it will work. So further attack surface. Okay. What you see is all the injection attacks, and another angle you can take to exploit this kind of bugs is through bookmarks. And the reason why is that there are two possible ways. One is the exploit the origin inheritance design in browser, and the other one again is input validation. Basically, the origin inheritance, its few words, is that if a user bookmarks a JavaScript URI, the JavaScript, and then clicks that malicious bookmark when it's using a trusted zone, then again you have the same class of attacks and the same class of exploitation. But this kind of attack is not new. I mean, this actually the fact that you could bookmark JavaScript was reported as a bug in 2005, and a lot of people were not actually didn't agree with this design. But actually, what I found out after making some research on the JavaScript UI is that it was invented for that purpose. And I don't know if you guys heard bookmarklet, the term bookmarklet. That's using JavaScript. And so what happens, so let's say you have a malicious bookmark, you click on it, and it's running the JavaScript. If in the moment you click it, you are on google.com, the JavaScript will be executed inside google.com. Or if you're in Yahoo, it will be executed in Yahoo, or any website. You have focus in the moment you click, the JavaScript will be executed there. Kind of universal cross-site scripting vector. But differently, if you are in a trusted zone and then you click there, then the JavaScript will be executed inside the trusted zone. And that's where I'm putting this kind of slide. The thing why I raise this is, even though you need the user in the first place to bookmark a malicious link, the fact that it's so easy to fool the user pushed me to raise this issue in the presentation, because there are so many ways you can fool the user from the UI. Like you can spoof the status bar, and when you think you are clicking on one link, you're bookmarking another one, and I'll show you some demos on that. And this is the definition from basically the guy who created the JavaScript URI. And he said, and you read, but also key for bookmarklets to run arbitrary script against the DOM of the current document. And that's which is the design function, and that was created for that reason. But at the same time, the design can be abused. So you can run, yes, you can run JavaScript in the current document. So you can have cross-site scripting, or you can have cross-content scripting. So Firefox 10.02 was actually vulnerable to this attack vector. What was fixed in Firefox 11. So let's say the malicious bookmark was clicked and you were using an extension. When you click the bookmark, then payload will execute in Chrome. And I'll show you a very short demo as well. So here, this was 10.02 Firefox. And here are some of the links. So here, I'm just posting it. That is a link, but on the, if you see the bottom, the user believes is bookmarking.yahoo.com, but it's not bookmarking.yahoo.com, it's bookmarking another one. So this is very easy to fool users into this. And I'm using the bookmark link functionality, right click on the link bookmark. And this is what you see. That's it. You don't see the URI. So even Firefox is not, well, this version of 5 was not even showing anything. I don't know about the latest one. I don't think there were changes. So let's say the user saves that. Yeah, I'm showing just a little bit of the HTML code there. This is I didn't find this trick, but what it does is the onMouse up event, it changes the URL to the one which is the malicious one. So that's why when you right click on it, the onMouse up event hasn't been triggered yet, so you still see the old URI, and then when you bookmarked the other one is the one that you're bookmarking. And I believe this was also submitted as a bug time ago to Mozilla. And this is what I'm injecting there. It's a long string from char code which contains my payload to execute inside the Chrome zone. And this is just the normal, what it does there is just standard cross-site scripting, so there are two of them. So I save both. Okay, this is the FireFTP again. So let's say the user is using this extension, then say, okay, I want to go to this website. Done. So that's enough to be compromised if you didn't check what you bookmarked. And again, this is because it's executing there. And this is what actually the guy bookmarked. This is the real JavaScript. And again, just talking to the XPCon components and calling CMDX. And here I'm just showing the cross-site scripting vector side. So, and this is, I mean, this is known, but that's the issue. It's immediate execution into the current DOM. And again, that was the other one which was bookmarked. Okay, in Opera the same thing, and what I will show you is with the 12.10. This is something which I actually told them about, and they say, yeah, we know about, it's fine. I'll show you what was the response. But what I found very interesting is that, again, using the same trick I showed you before at the beginning, like changing the mail application handler, you can basically change the mail application handler to using a UNC path. So you can point to your remote executable, and it will work. So I'll show you a demo actually doing that. So here I'm just setting my handler with Metasploit. It's just waiting. And this is the Opera. And this is just demo. And here you see what I put there was the response of the guy from the Opera security team. What he said is that basically says user have different needs and we will not want to prevent user from doing so if they want to. Say any changes we make to the way that bookmarklets work in order to improve user understanding or reduce risk exposure will most likely apply in all cases and not prevent them from working on certain URIs. Some may get additional protection, but I would hope that we continue to allow them to work everywhere they currently work. So basically the guys say, we are not going to forbid JavaScript URI in trusted zones, like Opera :config. And I say, okay, but this is bad. And they say, well, the guys say, as a power user, as an existing power user Opera for many years, I often made use of bookmarks on Opera pages. So I guess it's a business model they won't follow, but I personally don't agree with that. I mean, the average user doesn't need to run JavaScript URI inside the Opera config page, but it's like that. So here again, the same trick of before with Firefox. So fool the user into basically bookmarking a malicious link. And the first one is with the UNC payload. So basically set UNC path to a remote Meterpreter executable. And the second one is just a local bitter file execution. The way I'm doing this is, again, you need two conditions. One, the user bookmarks. The second one, when it clicks, is in the Opera config zone. So the JavaScript will be rendered there. And this is just the URL showing you that. Again, this is what it does is just set mail external application to the UNC path and then say, okay, then go window location.href mail2. That's enough to tell Opera to go and use the new mail client, which is the Meterpreter executable. And the one that you see on the top is, instead of pointing to a UNC path, is pointing to a local file system, like a local file which was CMD. And this is, again, is using the same trick on the mouse up event, change the URL. And I think it's, yeah. So again, this is Google, as you can see before. I just missed that. Again, you see on the bottom, you see .google.com. So again, I use the right click and Opera. And now, the difference with Firefox, Opera actually, if you click details, it will show you the real payload. So if the user is careful, you can actually avoid that. So now that's the bookmark which has been added. So the issue is only when this condition occurs, of course, is that if you click there, then it will execute inside this page, which is the config. And here you can see the mail part where the external application, there is nothing configured. So when I click there, the external application will be changed. And this is what happens. And my interpreter, which was listening, now it got the session, and it's basically working. And I also, another thing which I don't understand is why you can put a UNC path for the mail application handler in Opera, something which I don't understand. And but I noticed another thing with the Opera zones is that now I'm showing you which has, you see now has been changed to that executable there. What I noticed is that this is only possible in the Opera config zone. If you go to, for instance, to the Opera history one, the cross-script doesn't work. So it's really intended only to work in the Opera config zone. Here I'm showing that you can run JavaScript there, but if you go to Opera history, for instance, you can't. It's quite interesting. And I think this because I found that bug in 2008, so they probably did some protection there. But if you do it in also in the about, it doesn't work. Only in the Opera config. I don't know why. Anyway. And then we have Maxthon again with bookmarks. And this is a different type. This is input validation, and it's a funny one because you can use this function, which is add favorite function. And normally with the other browser to bookmark, you need action from the user. But in this case, with Maxthon, you go to a website, it will prompt you to bookmark the website. And what's happening here is that I'm not doing anything fancy with the URL, but I'm doing something with the title there. And what you don't see on the left side, there is an injection. And I'm using just some padding so that the user doesn't see that. I'll show you in the demo. This was in the previous version of Maxthon. So here, this is the page. So you go to the page, it will prompt you to bookmark. So nothing wrong with the URL, but it's on the left side. If you scroll a little bit on the left, you see the injection there. That injection will occur into there is a sidebar on the left with a star, and you would see. Say okay, I will bookmark that. And what happens when you click there is that will be executed. So you don't even need to click on the link. You just click on the star, and it will execute, and it will keep executing if you then click on the URL. And this is an input validation issue inside the sidebar on the left, because all these components, even the UI components, even if you see the sidebar can be rendered in a trusted zone. So if you have any way to inject there, that's another candidate for cross-content scripting. And this is what I'm doing. So basically, you need to do some padding to hide the injection on the left, but it works. So conclusions. Yeah, what I think personally is that the more the browser gets complex with more functionality, there is more avenues, more attack surface with this kind of bugs. And another thing which probably they should, if you're rendering stuff from the internet from untrusted zone, just use like a neutral zone, like about blank, and do not have that zone to interact with trusted APIs. Because if you do that, then you have the chance that untrusted content can run as privileged. Another issue is with extension add-ons. I think Chrome does better than Firefox in terms of extension. Firefox should probably follow a little bit the Chrome example, like put some boundaries or sandbox between the extension, because as we saw before, you can totally compromise another extension or the system if you have a vulnerable extension installed. And another point which I didn't put there, but this, at the end, for me, it's very simple injection bugs. Really, this is not complicated. It's nothing. It's not rocket science. It's just standard injection attacks. But the impact, it's tremendous. And again, that makes think about the security posture of some of all the browsers on the market. And that's pretty much it. You guys have any questions or any comments?